by elimination, and today is part 2 of that discussion. So let's just review what we've been talking about thus far. First of all, we talked about if we have an equation where the terms are written in the x terms first, plus or minus the y terms, equal signs, and then the constants. So this is called standard form for a normal linear equation. And what we decided was if you have a opposite or a negative pair, or excuse me, a zero pair in that equation, that something that you can do is just treat this like a big addition problem. Then you can add those two equations together, straight up and down. So that 3x, negative 3x, and this 3x would cancel out when you add them together. But when you add 5y and negative 8y, you end up with negative 3y. And when you add negative 14 and 6, you get negative 6. So to finish solving this, we're going to divide both sides by negative 3. And when we do that, we end up with a y value that is equal to 2. So now that we know our y value, we need to plug that back into one of the original equations for y. And it doesn't matter which one you plug it into, but you can do that to find x. And when I look at these two equations, I try to pick one where it looks like it's going to work out as easy as I can possibly get it to work out. So I guess I'm going to pick the top one because I'm going to multiply 5 by 2 instead of negative 8 by 2. So we'll see how that works out. So let's come over here, show our work. We've got negative 3x plus 5 times 2 equals negative 14. All right, now from there, I'll go ahead and solve that. So negative, let me click on my pen here, negative 3x plus 10 equals negative 14. And I subtract 10 from both sides. And I'm left with negative 3x equals negative 24. Well, right away you can tell if I divide by negative 3 on both sides, I'm going to get an x value of 8. So my final solution then would be 8, 2. That's where those two equations would intersect if you were to graph them. Okay, now what about part 2 then? So in part 2, what will happen is you'll notice that you have the equations both again written in standard form, but you may not have a zero pair in there. You might have terms that are the same. So in these equations, you have to look to see if you have a zero pair. If you don't, you may have to multiply one of the equations by negative 1 to make a zero pair. And if that's the case, then once you've done that, you can add the equations together like we did on part 1 of these solving systems by elimination, and then solve for the variable, and then just follow these same steps once again. So let's take a look at our first example and see what we mean. I went backwards. So here's one. I start looking here and I notice that these two terms are the same, so they're not a zero pair. So if I try to add this, they will not cancel out. So I'm going to multiply by one of the equations by negative 1, and I think I'll multiply the bottom equation by negative 1. And when I do that, I end up with negative 1x plus 2y equals negative 5. So now I've stopped, I'm not using this equation anymore because I've transformed it by multiplying it by negative 1. But now I've got a zero pair in these two equations, so I can use what I did on the last assignment of adding them together like this, and you end up with 1 plus negative 5 is negative 4, then the equal sign. Negative 2y plus 2y, those two cancel each other out. And we have negative 3x plus negative 1x, which is negative 4x. All right, that's good. So now all we have to do is divide both sides by -4. -4, -4, and that leaves us an x value of 1. All right, now we need to go back up into one of these original equations, and I'm going to maybe move some of the stuff out of the way so you can see them. Here's our two original equations. Which one does it look would be the easiest to plug a 1 into, and so for x, so we can find y? Well, I think I'm going to put it in this one right here. That looks pretty easy. So I'll grab me a marker. I'm going to take that 1 and stick it in for x right there. So I will have 1 minus 2y equals 5. Subtract 1 from both sides, and I'm left with negative 2y equals 4. Then if I divide by negative 2, I end up with a y value of negative 2. So there's my solution, 1 comma negative 2. So that's the process. So let's try another one. In fact, I probably got these steps kind of outlined again, so let's kind of review it. I multiply one of them by negative 1, like that. I find a zero pair, and I add the equations together in order to get rid of the zero pair, and then I'm down to negative 4x equals negative 4, and then I divide and finish solving it out that way. Okay, let's try this one here. So we've got 5y's in the second column here, and we need to multiply 1 by negative 1 so that we can add these together. So let's multiply the second one by negative 1. It really doesn't matter which one, but we'll do the second one. So then I'll have 8x minus 5y equals negative 17. Okay, at this time I'm going to add these two equations together. So I'm now using the top one and this bottom one down here. So negative 9x plus 8x is negative 1x, and 5y plus negative 5y cancels each other out, and 21 plus negative 17 equals positive 4. So if I divide by negative 1, I quickly see that x, that's negative 1. I see that x is equal to negative 4. All right, so what do I do next? Well, I bring one of these equations over, so I guess I'll try the top one this time. So negative 9 times negative 4 plus 5y equals 21. Negative 9 times negative 4 is 36 plus 5y equals 21. And let's go ahead and subtract the 36 from both sides. And that puts us at a number of negative 15. So 5y equals negative 15. When I divide by 5, lo and behold, x equals negative 3. So there's my two values, negative 4, comma, negative 3. So there's my solution to those two equations. And this is where you end up having to multiply by one of the equations by negative 1 to create a zero pair, and then do what we did on the first assignment to finish it out. Okay, we got one last one. We notice in this one the first terms are the same terms, so let's go ahead and multiply 1 by negative 1. Let's try and see what happens if I multiply the top by negative 1, since I haven't done the top one yet. So negative 1 times negative 3x would be 3x. Negative 1 times negative 2y would be minus 2y. And negative 1 times 8 would be negative 8. All right, so let's add them together. 3x and negative 3x, they cancel each other out. Negative 2y plus 4y is equal to 2y. Negative 8 plus 28 equals 20. All right, let's divide both sides by 2. We end up with y equals 10 in this case. All right, so we're going to take the 10 back up to one of these equations and plug it in. We'll go ahead and use the top one. So negative 3x plus 2 times 10 equals 8. Or negative 3x plus 20 equals 8. So if you subtract 20, so we subtract 20 from both sides, and we end up with negative 3y equals negative 12. And then we just quickly divide by negative 3. And so our final answer then would be y equals 4. So that's our two numbers. Actually, sorry, that's an x. So it'll be x equals 4. And so we end up with 4 for x, 10 for y, and there's our pair of numbers. Okay, so your assignment is going to be another worksheet called Solve Systems by Elimination number 2. All right, thank you very much.